Good morning, everyone. We're here to talk to you about Mega Canvas, infinite resolution, harnessing the power of UE in cluster rendering. So I'm Brice Maillet. I'm a team lead and software architect at Moment Factory, and here's...
I'm Zane Kozak. I'm CG Soup at Moment Factory.
What we're going to talk to you about this morning, I'll first introduce you to Moment Factory. Then Zane will give you an overview of Moment Factory's Mega Canvas history. After that, we'll cover some of the obstacles we face with offline rendering and how we manage them. Then next, it will share the story of this massive production and how we approached it creatively. Finally, I will dive into cluster rendering and the benefits and the challenges they bring. Then I'll wrap up with some final takeaways. We will try to leave 10 minutes for Q&A session at the end of the talk. So who we are? We're Moment Factory, a creative studio specialized in the production of immersive multimedia experiences and location-based entertainment. All right, we do it in public. That's our mantra. At Moment Factory, we do it in public, reuniting real people in real life with Unreal Engine. We're 450 employees. We've been at the forefront of location-based entertainment for 23 years, and we've launched 550 productions across the globe. Many of them are still operating. We have 5 worldwide offices to represent us and support our clients. So you can see there Montreal, Paris, Tokyo, New York, and Singapore. What we do? That's a big question. Our quest for new types of entertainment. At Moment Factory, we bring people together. From illuminating the forest to activating public spaces or custom experiences, and Moment Factory Originals pioneer new forms of entertainment. Our quest for new types of human experiences drives us to discover new ways to touch audiences and connect people. Inspired by the campfire's ability to gather people into shared experiences, we create moments that spark collective wonder. Moment Factory is a multidisciplinary entertainment studio specializing in the creation, design, and production of immersive environments. Our Moment Factory original and custom experiences weave video, sound, lighting, scenography, architecture, interactivity, and special effects into experiences that invites audience to wonder, touch, feel, and be inspired. Moment Factory Originals are a library of experiences that immerse visitors in engaging worlds with proven global box office success. They are designed to drive on-site traffic, create destinations, build brand awareness, and generate revenue. Here you'll see a video of some of our originals. At Moment Factory, we believe that when creativity and technology work in tandem, they propel each other forward. For our multidisciplinary talents, technology is more than just a set of tools. It serves as a source of inspiration and a catalyst for fresh ideas. Custom experiences now. They're designed to leave lasting impressions from live performances to permanent installations. Our scalable services are tailored to meet a variety of client objectives. So now a video for the custom experiences. Blurring the lines between the real, the imagined, and the digital allows us to unlock new ways to tell stories, engage the senses, and elicit strong, lasting emotions. Successful immersive experiences achieve this through the precise, often imperceptible orchestration of elements, both tangible and not. Music, motion, video, lighting, architecture, scenography, and special effects all merge into one seamless, unified whole. When done right, audiences are fully immersed, living the experience rather than merely observing it, and connecting with each other and the world around them in new and unexpected ways. You should have seen on the video that we're using a lot of real-time engine to create our experiences. One of them, Unreal Engine for sure. Then we'll talk to you about our history with the use of them now.
All right, let me just use my notes here. Thanks, Brice. All right, so we're going to get into mega canvases and what they mean. So what is a mega canvas? Here we can see a pillar, and we're going to draw a distinction here and refer to a mega canvas as a single surface that presents a singular vision. A mega canvas is a very large surface that requires custom resolutions to accommodate a prime viewing location. The idea is to maintain a retina experience, so HD, experience from that location. So a custom resolution must accommodate for how close the viewers can get, as well as how large that surface is. Now, mega canvases often exist in a full media ecosystem with other mega canvases. For example, here in International Terminal of the Los Angeles Airport. You can see multiple surfaces here. So the production of these full media ecosystems have many mega canvas surfaces that are produced at the same time and rely on the same resources, management, and planning. So it can be counterproductive to separate the various canvases and single out the largest. But that's what we're going to do, just to demonstrate an escalation of resolution over the years. In the top left corner, you can see some standard resolutions and how they break down into their total pixel count at the end. And we're going to be looking at different aspect ratios, starting with the one in 2013, which is more of a square aspect ratio. And there'll be all sorts of different aspect ratios throughout. So although Moment Factory's history reaches all the way back to the standard definition years, we're going to start in 2013 and start a climb over the ever-expanding summit of pixels with the massive media pillar and LAX. So as you can see, the resolution terrain is not a linear advancement, but a bit of a shuffle. One step forward, 2 steps back, and then 2 steps forward. In 2017, we established a base camp on the plateau of the tens of millions of pixel count. with a mega canvas at 14.6 million and one just shy of 10 million. And here you can see a longer aspect ratio. But hold on, we're not going to get too comfy here. We're not glamping. We're going to break camp and jump to the next plateau and take on a mega canvas with 62 million pixels. What's that? The scope of the project is not going to fit. Well, we'll divide it into 4 mirrored sections and punch-ins of unique content. And we'll sneak up to that 50 million plateau. So mega canvases are great fun for people that like complex, multifaceted puzzles. If you like relaxing with some UV time, consider some fine mega canvas time. At this point, we are now legit. We're on the 50 million pixel plateau with no fancy footwork, just pure pixels. And I know I said it would focus on a single media surface, but we're going to put that aside just for a second to have a look at a full ecosystem. So many different surfaces coming together for a full project. Oof. Okay, so 90 billion pixels. That's quite a bit. So first, it's interesting to visually compare these resolutions to clearly demonstrate the full scope of a project. Just comparing them next to each other dwarfs a single mega canvas. And second, this specific media ecosystem is a bit of an outlier, and we can clearly see how it comes together as a singular vision. So it does relate tangentially to the mega canvas examples. Here we can see how the surface comes together to present a anamorphic view into another world. And now we're going to come back down to a single media canvas surface again. And I wish I could remove the 90 billion one, but you can see that in 2023, we're actually quite a bit higher than we were in 2022. We had a big jump there, and it sort of related to Unreal a bit. So we're going to come back down to this. So in 2023, we had the pleasure to bring to life a concert series for the band Phish on the world's single largest mega canvas surface at the Sphere in Las Vegas. We're going to cover that in more detail later. Anyways, you can see that by 2023, mega canvases are starting to reach in the hundreds of millions of pixels, and that we're now sitting more comfortably on this plateau with the help of Unreal Engine. So we're camped out on this summit and ready for that plateau of 1 billion pixels to emerge from the fog. And we're going to split the remainder of the presentation here and focus on these 2 projects. One with a mega canvas, basically, the Sphere. So we're going to look at Unreal offline rendering, and then we're going to look at Unreal Engine with the real-time cluster rendering. In each of these sections, we're going to focus on the solutions that cracked open the possibility of the much larger resolutions. Before we crack that open, we're just going to establish the past challenges with offline rendering for mega canvas resolutions. We're going to break down the obstacles during production and integration. Then we're going to look at some of our solutions. So here's the Grand Magic Hotel, just outside of Disneyland Paris. This project was almost entirely rendered and produced in Unreal Engine. And this is the 90 billion pixel count, where many, many surfaces came together to make a full media ecosystem. So we had, it was comprised of 4 main capsules: a French garden, an underwater capsule, a sky capsule, and a forest capsule, each of which had 2 to 4 unique states. For example, the French garden had a unique state for each of the 4 seasons. And furthermore, there were 2 animated substates for each of these 4 states. To top that off, we had 4 custom transitions. And as you can imagine, it all added up to an enormous stack of renders. And let's remember, this is the 90 billion pixels per frame. Let's note. we're going to present some offline rendering obstacles that relate specifically to pipelines using CPU and GPU rendering engines. But I'm just going to I'll make sure to point out when Unreal Engine bypasses these obstacles altogether. So just look out for Let's Note. All right. So rendering resources have long been an obstacle for mega canvas production. Large resolutions can be taxing on infrastructure, especially if there are many capsules to render. Even more so if your render farm is constantly trying to keep pace with this steady march of resolutions. Often this is made worse when your render farm is divided among many other projects at the same time. Finally, last-minute changes can be extremely costly, especially if changes are made to the foundations of capsules, like the animation, for instance. Let's note that Unreal Engine will mitigate this first obstacle, and any mega canvas render pains will be far less acute. So software resolution limits can present a dead end. For example, look out for a 30K by 30K max resolution cap in After Effects. Also, current GPU hardware limitations can cap us at a max texture resolution of 16K by 16K. Now, Brice will tell you a little more about that later, that we're getting around that with using cluster render for our offline rendering as well through Unreal to get past that. Let's note that if you can do all of your color grading and get everything done directly in Unreal, you're going to save a lot of time and avoid any dead ends with using composite software. Another thing that comes up is complex templates. When we're using, so complex templates can be hard to decode. Here's just a UV layout where basically this is what a projection map show would look like. Very hard to understand, and it can take some time to get acquainted with it. So often now that slows down production, and we end up having a back and forth workflow, which just slows everything down. So it can also take a lot of time for a new artist to get on board and become acquainted with these complex templates. And then finally for integration, as well as production, so data storage is an issue, and then for integration, transfer speeds are a really big issue. So mega canvas resolutions can be heavy to store and work with, especially if you're compositing in EXRs. And that can be even worse if you're simulating detailed effects that have large data footprints. During integration, delivering many large videos can be a logistical challenge, especially if the on-site download speeds aren't adequate. So all this compounds to a slow turnaround for any on-site adjustments. All right, so we'll quickly look at some of the solutions. And some of them are just common sense. So like planning ahead. So you want to make good use of tools like spreadsheets and production tracking software to keep everyone on the same page. It's a good idea to hire some amazing content coordinators and content technical directors to help out with this organization. With these resolutions, we need to make sure we're making good choices. So previs is always essential. And VR previs is often the perfect tool for this job. It can validate things like animation speed, scale, and characters. So previs is extremely useful for saving time when we show up on site for integration. Since we've already been working in context, we're going to have far less surprises on site. Here you can see we also have a mock-up of the sphere, and mock-ups can be useful as a place to kind of gather around and talk about some of the aspects of the production so far. And some people can do that with VR too. We hang around and watch what the person's viewing as well. It can be just as good for some people. Also being efficient, so use proxies, manage your samples, use temporal denoising. And software limitations, so we kind of discussed this earlier. You can get around those with like puzzles and mirroring content. And then I already talked about the cluster rendering. So for your complex templates, it's a good idea to do a lot of iterations and mock-ups to validate your template as you're building it, just to make sure that it's going to be human readable and as efficient as possible at the same time. And of course, use the previs tools to help understand how the template is mapping out in context of your location. And data storage, so work light and clean up as you go. Collapse your working comp into the essentials if you can. And if you can nail it in previs, you're going to save a lot of time with unnecessary back and forth. And if need be, you may need to set up an offsite download location to help yourself out. There are some specific solutions inside of Unreal that we've been taking advantage of. And one of these is with Unreal, we can go a step further than previs and work instead within a digital twin of our on-site location. So this way we can make adjustments directly in context. And so here you can see a novel use of render targets that my colleague Mokaram implemented to help sculpt the hills and keep the consistency from one media surface to the next and create the illusion. So this allowed him to visually solve for a complex template mapping just automatically, didn't have to think about it. And that allowed him to stay in a visual artist's flow state, making sure that everything was lining up and looking beautiful. All right, so although Unreal Engine can help ease the bottleneck of render resources, we still have many of the same obstacles to manage, leaving us with an unflexible position where any on-site observations or artistic insights are just left on the table. And that's just really sad. However, with real-time cluster rendering, we could put almost all of these offline rendering obstacles aside and focus on what really matters. And that's a huge win. So it allows us to keep agile during integration and act on any of these opportunities we found. And that just allows us to create more affecting experiences if we're able to capitalize on those observations. OK, so we're just going to set the stage for cluster rendering for Brice and have a look at the unique requirements of producing content for Phish live at the Sphere. So the Sphere, by essence, is a location-based experience, a one-of-a-kind venue that could only happen in the exuberance of Las Vegas, with a gigantic spherical exterior called the exoscreen, and a spherical internal venue with the world's largest LED screen. The internal screen envelops viewers within an immersive experience. And for Phish Live, the band had an idea to visually represent some of the states of matter with a substantial imprint of the psychedelic era, abstract graphical tendencies, goofiness, and odd worlds. So the classic rock did stick to the four main classical states of matter: solid, liquid, gas, and plasma. These four states of matter were a convenient choice because it wasn't just a single show, but four unique shows that took place during the course of 4 nights in a row during the residency. So the four states of matter, solid had a set list with 18 songs, liquid 16, gas 17, plasma 17 songs as well, for a total of 68 songs. Good start. Songs' durations ranged anywhere from 3 to 30 plus minutes, meaning we had a full 12 hours of show to produce on a 16K mega canvas. And over the course, and of course, because those figures are not extravagant enough, all of this had to be done in the span of 3 months. So the live concert industry, we're always kind of in a rush when it comes to conceive and run the tours. But this magnitude was not known to us yet. It's kind of an outlier. But let's have a look at some of the footage of the show just to get a better understanding of what it's all about. So I repeat, 12 hours of show at 16K resolution to be done in 3 months in this tiny low-key venue. I'd like to know if there's anyone out there that would have said, okay, perfect, sounds good. Piece of cake, let's do it. Please raise your hands. Oh, you might be brave. Yeah, come talk to us after the show, and we'll probably be working together in the near future. But wait, it's Vegas, it's Phish. Something else was bound to happen. And as any good story, there's a classic dramatic twist, a disruptive element. And we call it the jam twist. So Phish is a jam band. They're well-versed musicians that improvise a lot around their songs. Here's a show timeline with each of the 4 nights and their set list. Traditionally, music shows are a beast running on timecode with pre-programmed cues to control the ensemble of mediums during the spectacle. There's normally a little space for improvisation when it comes to all of this technical aspects surrounding the artists on stage. But we had quite a few jam songs to work with, so we had to think about how to design for the unpredictable. What's the best creative approach to tame this chaos? Well, if we wanted to simply jam, what if we wanted to simply jam as well? Creating content so we could visually jam with the band to be part of the grand improvisation. Our visuals needed to be able to adapt and go with the flow. We would need to have the ability to expand or contract the content to keep it all evolving. But how do we visually jam? Well, live VJing gave us the perfect foundational model. So we went with 2 input methods for VJing, classic and real-time. For the classic approach, we prepared a huge amount of pre-rendered assets and loops, building a bank that could be used on the fly. Here you can see we had our classic DCC render pipelines, as well as some generative AI pipelines that we were been experimenting with lately. For the real-time approach, we added to this media bank of several Unreal and Notch capsules that gave us a virtually unlimited playback time, which we can control and modify live. We carefully selected the most impactful parameters, giving us a depth of expression to the VJing itself. For this, we would need an extremely flexible content playback system to achieve this visual live jam. So for the Phish shows, we brought in a disguised playback system. It was comprised of multiple render nodes, which were used as a cluster render to divvy up the 16K resolution. These nodes work together as a cluster and are gen-locked to stay in sync. We could ingest and stream pre-rendered media as well as the real-time content. And we could have a total of 3 layers at once to be composited live. One of those could be a real-time stream. And for control, we used the DMX protocol to give full control over the content parameters directly from the Grand MA lighting console. For real-time, the parameter values were exposed for live hands-on control during the shows. Usually it was about 10 or so that could be accessed. And additionally, controls were used to drive compositing blends and modes for the pre-rendered content layers. Here we can see Abigail Holmes, the creative and show director, during the show with the Grand MA lighting console. So that's what it looks like there. We all sat there watching her drive this psychedelic spaceship, waiting patiently for our turn that would never happen. I don't think any one of us wanted to be responsible for crashing this massive ship. But it looks so darn fun. So Abigail, she had the wild idea to drive 12 hours of show over the course of 4 nights all by herself. She made collections and composite sets and controls mapped out that she knew would evolve with the music. So she could tap on any one of those setups and have access to a new workflow. So you can see the thumbnails there. And just quickly go over mesh mapping. That's what we use to go onto the sphere. So for the offline rendering content, we had to conform to the spherical formatting, and that added an extra step. But for Unreal, we were able to use skip that whole pixel space formatting and output directly using mesh mapping in Disguise. And here's just kind of a small demo of what that might look like, where you have one surface split amongst 3 different cameras. Each of those cameras would be a separate node. So this made things very simple. Well, for me anyways, it was just really simple to implement mesh mapping, but not so simple to manage in production. There were lots of workarounds to find, and Brice will get into those a little later. So I hope that gave you some insight into the unique demands of this project, and I'm going to hand it back to Brice.
Thank you, Zane.
You're welcome.
So yeah, here's my turn, going more on the technical aspect. We worked with the Myris. Quick note about that. Myris team worked on the implementation of that project. All those explanations, pretty cool project, right? Let's dive a little bit deeper into the technical aspect of that project. So Zane already covered many of these points, but now I'd like to focus on the real-time aspect of the project. Yes, everything had to be dynamic during those jams moments, so we chose real-time rendering. We needed to incorporate numerous parameters that the VJ would manipulate during the show, adding a lot of complexity and requiring extensive testing during the creation process. Yeah, thanks. We brought a disguised playback system, as Zen said, and based on our prior experiences and the project's creative demands, we determined that Unreal Engine was the best ideal solution. But first, for those of you who don't know, here's a quick overview of what is a cluster rendering. In this example, we have 6 machines, each responsible for rendering a portion of the final image. That's the basic concept of cluster rendering. However, for it to function properly, communication between these machines is essential. The primary node communicates with each machine and centralizes the decision-making for the entire experience. The cluster can consist of any number of nodes, and each viewport, or part of the render, can be of any size, though we typically try to limit it to a maximum of 4K. And just to give you a sense of scale, in the sphere we had 25 nodes working with 2110 SMTPE for the final resolution of that 16K we talked about earlier. So now that everyone has a better understanding of what end display cluster rendering in Unreal is, here's a simple case study of one of the scenes we worked on. You can see all the parameters we had to expose and manage for that scene. And we're already familiar with the interfacing with DMX, a live lighting protocol. And for that aspect, everything went pretty smoothly. For those of you who don't know, we actually worked on the DMX plugin. Moment Factory worked on the DMX plugin implementation with Epic, and the actual DMX template was made by us. And actually, from that conference yesterday, we can't wait to test it with the new Mega Lights feature in the upcoming 5.5 version of Unreal. So, there was some challenges. With that said, everything shouldn't have gone smoothly, right? Well, not exactly. We ran into a few issues. First off, we noticed a significant performance gap between running locally on a single machine and running in a cluster. The cluster logic itself demands a lot of processing power to handle communication and messaging between nodes. The more nodes you have, the more processing power it requires. Remember, we had 25 nodes for this concert series. With that in mind, challenge accepted. Optimization became a key element of the project, and our talented collaborators at Myris chose to use a vertex displacement for many of the animations, which helped save valuable FPS along the way. That's one of the output effects that we had. Another challenge, screen space effect don't work in cluster. And the reason for that was that when using multiple cameras in Unreal, each server, each node had its own unique viewpoint in the scene, creating small seams in the canvas. We had to make the decision to run with it as it was for the human flow capsule. Underwater just does not sell without the volumetrics. In projects like this, compromises are inevitable. You don't truly know what will happen until you see it on screen, and then you have to make some tough calls. Another key point, when running in a cluster, everything needs to be deterministic, or you end up with unexpected results in each render. Keep in mind that each machine operates with its own processes and clock. Lastly, our team had to adapt to working iteratively, starting with a proof of concept and then refining it to make it beautiful afterward. You were talking about data storage, right? We're talking, just to give you an example, a sense of scale, we're actually working with hundreds of terabytes. And for the Sphere, we talked about petabytes. That was the first time the team talked about petabytes of data. It was, yeah, we're a little bit afraid. And because we're running with an Unreal project, we were actually talking about tens of gigabytes, not the same scale as you would understand. So usually any major update with the pre-rendering workflow takes 24 hours plus any update. Now we're talking seconds, basically, with the update of the Unreal Engine project on the nodes. That cuts out a lot of times. And remember, we only had 3 months. Slow to start, but fast to finish. Actually, the foundation of the project, we're taking time to build, like systems, libraries, mechanics. But fast to finish, because working in real time allowed the creative team to iterate really, really fast at the end. Once everything was set up for a real-time project, it was easy for us to switch some of our pre-rendered capsules from our other digital content creation softwares to Unreal, and we were able to free some bandwidth for other capsules. And we added the benefits to those capsules of the real-time or parameterized effects on those capsules. So that was pretty neat. And yeah, testing. Go back on my slide. As always, we're working with, as we said, a lot of parameters, a lot of things that are dynamic, and they had to test a lot to see if all those parameters are like interacting properly with each other. Your turn.
Yep, thanks. So after 4 nights of seeing the Unreal worlds come alive at the Sphere, we were still feeling surprised by moments that were never set in stone, but could unfold by chance. The parameterization had enough subtlety to create the unexpected. And we felt we had just scratched the surface of this live VJing in Unreal in the Sphere. So over the course of those 4 nights, we had many more ideas as we watched the concert series unfold. And we all just wanted to keep on jamming. There was a specific moment that really stuck out for me. A school of Phish was slowly emerging from the unseen depths and becoming larger and larger until they were larger than life. And everyone responded almost like a wave of joy as the Phish passed over us. So it was truly an unexpected and magical moment that I don't think even after working on this project for 3 months straight, any of us expected.
Thanks. So takeaways after that experience for us, Moment Factory, based on our experience with the cluster rendering. First of all, it's not a one-size-fits-all solution and does not answer like every project. Mostly it requires costly infrastructures and has certain limitation in style and compositing, as we saw before. However, when the need arises for an interactive, a dynamic installation on a large canvas, it's a clear choice. In fact, we're currently using real-time cluster rendering with LiDAR sensors for an interactive experience that we're developing at the moment. What's next for us? We're continuing to develop our expertise with this technology, both for new, innovative, real-time applications and pre-rendered content. We're always trying to hack the technology and move further. We're constantly learning and exploring new solutions, a new way to hack the tech, new way to push it forward, and how we can harness the full potential of this technology.
Thanks for coming out.
Thanks for you.